So before this lesson, I just wanted to make a note on notation. For most of my lessons, I will be using the notation f prime of x, but I just wanted to note that there's also other notations. One in particular being, I'm not sure if I'm pronouncing this right, Leibniz notation? Leibniz? I don't know. Whatever. It often looks like dy over dx. It's the same thing, it's just the change in y over the change in x, which is what the derivative is. There are just multiple ways to write the same thing, and for most of my problems I just prefer using f prime of x because for most people it's just not as confusing, and sometimes you forget what the dy dx means. So, but later on we'll probably be using that more often, especially when we get into integrals and stuff like that. So I just want to make a note on that. So for the lesson today, though, we are going to be talking about exponential functions and their derivatives. So let me get a different color. So the exponential rule for derivatives is if f of x equals a to the x, f prime of x equals a to the x times the natural log of a. And then there's a special case also to note. If you have e to the x, then the derivative is just e to the x because, well, first of all, for those that don't remember, e is just a number. It's approximately 2.718. That's the approximation of it. But it's just another number like pi or something like that. But when you take, so say we use this rule up top here for this, you'd get e to the x times the natural log of e. Now that's fine, but the natural log of e equals 1. So that's why you can just say that. So now let's get to some examples here. We'll be using this new property here along with some old ones, specifically polynomials, things that have more than one term, and constants. So for example 1, 5 to the x minus 7e to the x. So this one, it's a polynomial, there's multiple terms in it. So we just take the first chunk here, using this property up here, so we get 5 to the x times the natural log of 5 minus 7, which is just a constant, so we just multiply it out, e to the x, because remember, e to the x is a special case. So then to just kind of simplify it a little more, you get the natural log of 5 to the x minus 7e to the x. Now, you could have left it in that form, it doesn't really matter, just I prefer to write it with parentheses. So on to the next problem here. That's just a constant, so we multiply it out. And then remember, we multiply it by a, which in this case is 1/2, or the natural log of a. So we get 4 natural log of 1/2 times 1/2 to the x. So it's pretty simple. So let's say we wanted to take, let me get a highlighter here, 1 second. Say we wanted to take the derivative of this here, which I just highlighted yellow. That is called the second derivative, but let me show you how we would do that. So this is f prime right here. So if we want to find f double prime of x, which is just the derivative of the derivative, this is just a constant, the natural log of 5 approximately. So it's just a constant, so you just multiply it out like with the 7 up here. So you get natural log of 5 times 5 to the x, natural log of 5, because now that is a, minus 7e to the x. So that would be f double prime of x right there. And so that's the conclusion of exponential functions and their derivatives. Next we will be talking about derivatives of natural logs.